Spotify. Yo, what's up guys? Welcome to this new stream of my channel. Okay, perfect. Sound and everything is good. Nice, okay. So as you can see in the title, today we are finishing the math library, which we started yesterday with the vectors. I can start it. I think we didn't. Yeah, we did compile with vectors, and we had this in the shader. Okay, now I made matrices support. Like, I didn't make matrices support. I just made a scaffolding for it, but I didn't implement like most of the things. But I have a matrix 4 which just consists of 4 rows of vec4s, which is pretty easy. And yeah, now I want to test uploading it to OpenGL, so let's make a matrix 4 value pointer. Yeah, my keyword is weird. So value pointer matrix 4 here, and then we have a float pointer. Red is equal to malloc yeah, okay, so let's include stdlib first. So malloc size of matrix 4. And then we do red okay, let's do 4 I32 I is equal to 0, I is less than vector 4 element count, I plus plus float what the fuck, no, red at I is equal to m dot row 1 at I. Yeah. And now we need to do that for every row. Row 2, row 3, and row 4, and return red. Yeah. I hope this will work. Wait. Ah, no, it won't. So we do vector 4 get vector 4 value pointer m dot row 4 at I. So let's do m row 3 row 2, row 1. Easy. So now it should work, I hope. So let's first compile. Okay. In matrix 4, 17. Okay, obviously it's bool 8. Bool 8. Oh, where is it? In 5? In 70. 57. So here. Okay, yeah, we can ignore that. Okay, so now let's make a GL functions, a extern pointer function GL uniform matrix uniform matrix for FV proc GL uniform uniform matrix for FV 3 2 yeah, and let's copy that and 1 2 3 this this and this and this and this. Nice. Okay, so we have the OpenGL function. Now in the shader we just need to implement a way to upload a mat4. Okay, so let's do vector and matrix.h, which just makes pragma once and function include matrix 4 G and shader include math matrix. Matrix 4 is GL uniform matrix for FB, GL get uniform location, program is program ID and name is the uniform name, count I think is 1, transpose is false, and the value is matrix 4 value pointer, uniform value. Yeah, uniform value. Nice. Okay. Yeah, so in the shader, let's take in a uniform mat4 U projection and multiply it with that. And then we do shader program upload mat4 red shader u project let's make u proj. Oh, and we have this convention. U proj and matrix 4 create. No, matrix for identity. Yeah. Okay, so now we should see the exact same result. Perfect, we don't see anything. I love it. Yeah, perfect. Okay, so let's see. Returns red, and let's do for u32 I is equal to 0, I is less than size is less than 16, I plus plus log info log info percent f let's do percent I value, and this is I, and f is red at I. Okay, this is obviously wrong. Okay, so this is right, and then it's not right anymore. But why? Ah, I'm dumb. At 4, at 8, at 12. Yeah. Okay, we still don't see anything. It still doesn't work. Because this is wrong. So let's do int j is equal to 0. Yeah, this is so fucking dumb. So let's have it like this, and then let's do int u32 j is equal to 0, and at j, and then we do j plus plus. Yeah. So let's do it for everything. Okay, I hope this works. But maybe like OpenGL takes in matrices a different way, which I hope is not the case. But yeah. Let's see. Still. Oh god. Okay, so let's scrap this first, and then let's do I don't know if we can return an array, but I don't think so. So let's do red. Can't we just do red at 0 is equal to m.row1.x, and then we do like we fill it in like that. Should technically work. Okay, so we can do this and then copy it and do 3, 4, 5. Let me. Yeah, okay, I'm sorry for that, but I needed to check. So on 5 watchers. What's up, guys? Okay. So let's try this. Yeah. So 3, 3, 3. This is 6, 7, 8. And then 9, 10, 11. Wait, why? 11. Row 4. Row 4, row 4, row 4. Yeah. Oh, I'm dumb. I'm so fucking dumb. We're working with vec force. No. That's the reason why. Oh god, so 5, 6. 7. W. 8. 8. 9. 10. Row 3 dot W is 11. Then we have 12, 13, and 14. Still doesn't make any sense. So 0, 1, 2. So this 4. This is 4. This is 4. Oh, and that's 3. Okay, so at W. Now it makes sense. Nice. So let's test it. Yes, perfect! Perfect. Oh my god. I love it. It works. Very, very nice. Nice. Perfect. Okay, so we have matrix. We can upload matrices to the shaders with our own OpenGL functions, which is really, really nice. So now let's keep working on on matrices stuff. So add scalar is just we do vector 4 adds scalar, no, add scalar. Source is m and scalar is source is m.row1. And here it's row 2, row 3, and row 4. That's it. Scalar subtraction is the same thing, just subscalar. Very nice. So sub scalar. Oh, yeah. Let's do m.row1 like this, and do wait. Red dot. Red dot. Yeah. Red is equal to create like this and return red. But now we just subtract the scalar. So same thing, but with subtracting. Yeah, so this works perfect. Subscalar is the same thing here, but we do sub. This is very nice because like matrices just are vectors, like arrays of vectors, which makes it a lot easier. Scalar multiplication. just mul or mult. Mult by scalar, we do that, and mult divide. So diff scalar, div by scalar, very easy stuff, but yeah, like we're going to do like translation rotate. Oh, I'm sorry for the, oh fuck, probably like the code is far too small. Very sorry for that. Okay, so addition, add, what? Oh yeah, I thought, what the fuck. So matrix addition. We just do vector 4. Yeah, so first we do matrix 4. Red is equal to matrix 4. Matrix 4 create. Wait, let's do equal to M1. Oh, but let's do it like that. Matrix 4 create. I hope the code is visible and not too small, because I have a high resolution monitor which makes it like appear smaller on lower resolution monitors. Yeah. Okay, so m1.row1, m1.row2, m1.row3, m1.row4, return red. And then we do vector for add v, source m1.row, no, red.row1, and we're adding m2.row1 to it. Row 2, row 3, row 4, 2, 3 and 4. Add matrix is just that, but we have source row 1 like this, and then nice, subtraction, just that. Vector for sub v, I guess. Subtract matrix, easy. Sub multiply, also very easy. I think it's mult vector. Are you using GLM for math? No, I'm programming in C. I'm making an engine in C without any libraries. And GLM is a C++ library, first of all. And second of all, yeah, I'm doing it without libraries, so I'm currently creating my own library, my own math library. So yeah, as you can see, matrix 4. Yeah. Yeah, welcome to the stream. Glad to see you here. What's up? Yeah. Yes, so source row 1, and this is and we do yeah, like that. Divide should be the same. Diff divide v, and now like the last steps. So divide v. Transpose. Oh, need to look that up. Because like I made a math library in C, which is called CML. Already is done. And like the parts, the hard parts, I'm just going to copy. Because, yeah, makes sense. Wow, nice man. Yeah, thank you. Thank you very much. Where do I have transpose here? Yeah. So transpose is just allocating and RC. Let me be right back, guys. Someone is calling me, I'm very sorry. Okay guys, back again. Yeah. So transpose, I thought what the fuck? So I'm just copying the matrix into new memory. That's what the function does. I don't exactly know for which reason I should do that, but I think transposing a matrix is something completely different. But yeah, let me look up transposing matrix. Oh, I'm dumb. You just swap the rows and columns, I guess. I can't open the chat. Why? YouTube is not loading. Oh god. Yeah, whatever. Just have it on my second monitor, I guess. Okay. So transposing. I think that means the transpose of a matrix is just flipped version of the original matrix. So 147. Okay, a bad thing, a very bad thing, is that I don't have any way of like accessing columns, just rows. So I need to find a way of accessing columns. So let's do let's do a vector for matrix get column by index, or get column, just get column index, and then we do first we do a assert message index smaller than vector 4 element count. Matrix column index out of bounds. Yeah, and then we need to have a vector for red is equal to so the first row is 0, 4 and 8, I guess. Okay, so I'm going to do that like vector 4 create so first we need matrix values is equal to matrix 4 get matrix 4 value pointer. Oh, obviously we need a matrix from which we want to get it. It's matrix for m32 index. Matrix for so value pointer of m. No, we don't need pointer. Create matrix values. And we do u32x index is equal to 0 plus index. u32y index is equal to 4 plus index. u32z index is equal to 5, 6. So 5 is y. Z 6, 7 is W, and 8 is X again. Z again, I mean. So we do index 1. Yeah, okay, let's do like that. As you get to 8 plus index. And then we do matrix values. No, we do matrix values at x index, matrix values at y index, matrix values at z index. 12 plus index is w index. Matrix values at w index. Then we do return red. So if I'm not dumb, this should work. But let's first compile it. Oh, 20 errors. 20 errors. Oopsies. 77. Passing vector 4. Vector 4 pointer. Aha. Ah, okay. Needs to be this. What the fuck? 78, 79, 80, 31. 93. Okay, I think I get the drift. We have 110 Then we have 116. Yeah, done. Wait, why are we even taking it in by a pointer? Doesn't even make sense. Okay, let's see, there was now 12. $170. Yeah, okay, so basically it's the same thing everywhere. So I think this, okay, yeah, they have 4 times 3, which is 12 arrows. So let's check that. Okay, perfect, works. Very nice. Okay, so now YouTube is starting on my phone. Okay, perfect. So I have 3 monitors now, like a second monitor on which I can do stuff, and my phone on which this chat is. Perfect. Okay, so now we can delete transpose, I guess. No, we can't. Oh, I can't obviously. But now let's check. Let's check. Oh, we haven't even got a matrix for print function. So void matrix for log, matrix for m. So we do that, and then we do printf. Wait, for? Oh no, we can't do that. Matrix for. Okay, so printf. Now we do. Sorry, we do this. Then we do vector for log m dot row 1, and then we do that. Yeah, and copy it. Row 2, row 3, row 4. Yeah. Okay, so let's see. We do matrix for is equal to matrix for create. Let's have a vector for. Let's just do matrix for identity. Yeah, no, it's not fun. Matrix for create. Let's make that's a transposing matrix. Let's have, okay, they do this, but let's have matrix 3, but no matter, it doesn't matter. Okay, so we have a vector for create. So 1, 2, 3, 4. Then 1, 2, 3, 4, then 5, 6, 7, 4, 5, 6, 7, then 8, 9, 10, 11, and 12, 13, 14, 15. Why isn't it 16? We have 1 value, 2 values, 4. Needs to be 16. Why am I dumb? So 1, 2, 3, 4, 5. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And let's have it like that. Yeah, and then we do first let's try out a matrix logging. So matrix for log. Why is that not there? Oh, matrix log m. What? What? What the fuck was that? Whatever. Oh, okay. We don't have a \n. So, logging a vector. Oh, logging a vector doesn't do a \n. So \n. But it's okay that it doesn't. Let's have a parameter. Bool new line. Oh, I think it's too clunky to have it like that. We can, like, just for code cleaning reasons, we do vector log new line, which is just that. But we need to implement it for every kind of vector. Oh, God. Okay, whatever. So vector 3 log new line. Log new line like that, and \n. Nice. Now for the vector 2. Actually was very fast. New line. And done. Nice. Yeah, so after every, like, that guy? No. Okay, so this should now work, I guess. Yeah. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So what we should get is 1, 5. Yeah, okay, so let's do vector 4. V is equal to matrix 4 get column. Get column. Oh, matrix. Matrix 4 get column, and then we have matrix 4 get column, this matrix, and 0. I do vector for log p. One, 5, 9, 13. Perfect. Okay, nice. So let's do it 1. Oh, I think it maybe it won't work. 2, 6, 10, 14. Okay, perfect. That works. Nice. Nice. So my way worked. Very nice. So we can do yeah, whatever. We could do vector for element count times 2, element count times 3. Yeah. Okay, now transposing is just well, okay, let's just don't do that. Where's transpose here? So transposing what we do is So matrix for red is equal to matrix for create by value 0 and then return red, and we do for u32 I is equal to 0, I is less than 4, I plus plus vector for element count. So we have that. That's the row. C for column. And red dot row. Oh. Let's do get row, because that makes things very much easier. So here and matrix values is that zero plus index, this is 1, 2 and 3. At index, no, it's not right. Index 1, so we do index times vector for element count. Because like 1 4 is 4, yeah, that makes sense. Yeah. So let's do for u32 r is equal to 0, r is less than vector for element count r plus plus. This C. We do red dot red but this can't change it. Ah fuck, Digga. Okay. Let's just do red.row1 add what the fuck is this? Very hard. Maybe we like this is so like let me 0 1 or let me give that example a try. So we have Ah yeah, it's easy. We just do ret dot row 1 is equal to matrix for get column 0, row 2 is column 1 from this matrix, and row 3 is column 2 and row 4 is column 3. That's it. Very easy. I just was overthinking it a lot. Easy. Okay, so let's try that. So yeah, matrix for transposed is equal to matrix for transpose and then we do matrix for log transposed. Okay, and delete that guy. Build. So wait, 1, 2, 3, perfect. Yeah, that's it. Or is it? No, it's not. Oh, wait, 1. No. Oh, it. I'm dumb. Like it is. But so 1, 2, 3 is what we started with. Ah, and then it's 1, 5, 9, 13. Yeah, that's correct. And 1, 2, 3, 4 is here. Yeah, okay, that's correct. That's the example. Like, see, you have 1, 2, 3, which is here, or 1, 2, 3, 4, and 1, 4, 7, which is like this, and so this is 1, 5, 9, 13. And we have 1, 5, 9, 13. Perfect. So we transposed the matrix. Nice. Okay. So this was actually easier than I was thinking, because I complicated it just too much. Very nice. Okay. So now let's do translation, rotation, scale and stuff. So yeah, let's do a radiance thing. So radiance.h, we do pragma once and include /core/default float degrees to radians. Float degrees radians.c include radians.h like that, and then we do this magic stuff here. Just don't ask. Okay. So we have radians. Now let's do matrix transform. Or should we first do like matrix 3 and stuff? Oh wait, this is here. Yeah, I think we need matrix 3.h. So let's copy a matrix 4. We don't have a row 4. We include. We just replace 4 with 3, I guess. Yeah. Matrix 3 compare, yeah. I think that's correct. Matrix 3.c, matrix 4, 3. So that's first made matrix 4. We replace that with matrix 3. And then search up 4, which is still a lot. And vector 4, we replace that with vector 3. And then we check for every 4. So this is not here. This is also not here. This is not here. And this is not. And this is wrong. And this like that. Yeah. And this is wrong. Row 3, yeah, like that. And oops, 3, 4, 5, 6, 7, 8. So row 3, X, Y, Z, yeah. This is like that. This is like not here. Compare. I think this can stay. Oh no, this can't stay. This is wrong. Row 4 is wrong. Row 4 and this and this. Row 4, this. Row 4, this. Okay, so this is very monotone, I know, but it has to be done. I'm very sorry, but it's just the way. Don't need that, we don't need that, we don't need that. Vector 3 element count. 0 plus index. Yeah, okay, this is nice. W index doesn't exist. Wait, so 3 plus 0 plus index, so and 3 plus index would be correct, yeah. And W index just simply doesn't exist. And return red. Yeah, this is not existent. This is not existent. This, 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 this. Yeah, okay, nice. No, this is not there. And we need a... Yeah, okay, we have a big fish. Okay, so let's run. Okay, obvious. But that's very few errors, which is nice. You are joking. This is actually working. Nice. Okay, so let's do matrix 2. Copy matrix 3. Change every 3 to A2 and remove that and that. Yeah. Create matrix 2.c. And then yeah, just copy that. So vector 3 replace with vector 2. and matrix 3 with matrix 2. We don't need that. Don't need that. Yeah, this is not right. Row 1 dot this like that, and this is not here, and this is 2 and 3. This is like this. Just like that. Yeah. Like this. Row 3. Just remove every 3 kinda. Row 2, row 3. Yeah. Okay, so yeah, this is already working. Perfect. Nice. Subtract matrix. Perfect. Let's compile. Okay, a few more. U22. No! Oh my god! U22 replaced with U32. Yeah. Z index unused variable. Z. Index is obviously unused because we don't need it. Create in 70. Yeah, makes sense. Okay, so now we have matrix 2, 3, and 4. And radians. So now let's do matrix transform finally. So pragma once. That's gonna be a tough one, but I have already implemented it, which is good. So let's do wow, Sailing Game Center. Wow, why wow? But welcome to the stream. Glad you're here. So we need vector and matrix. And by the way, in matrix we need to include matrix 4, 3, and 2. Yeah, thumbs up. Thank you very much. Appreciate it. Thank you. Very nice. Okay, so now we need a matrix 4, which is just, how should we call it? Translate matrix translate, or translate MV for matrix vector. Yeah. So matrix 4 M and vector 3 V. Rotate. So matrix 4 rotates MV. Yeah, MV A for angle, MV angle. So matrix for m float angle and vector 3v. So matrix for row scale mv, matrix for m and vector 3v. Now now we have like, let's do the camera stuff. Let's do look at vector 3i, vector 3 center, and vector 3 up. Yeah, let's do a matrix for a perspective matrix, look at matrix, perspective matrix, which is float FOV, float aspect, float near, float far, yeah. Then a matrix for orthographic matrix, float left, float right, float bottom, float top. Yeah, that's it for the necessary translation, transform functions. So let's include matrix, transform, and make all of those functions happen. Okay, this is going to be a pain to implement. So first translate. This is pretty easy. You have a matrix for red is equal to yeah, we can do m, yeah, return red, and we do red dot row 3 dot x, I mean row 4 dot x, plus equals v dot x, and this for y and z, because translation is in the last row of the matrix, happening in the last row of the matrix, and we just need to plus that because like it's an identity matrix. It should be an identity matrix, or maybe something different, could not even be an identity matrix, but we just plus it. So we add the translation that we gave to the translation of the matrix, which is already applied, and yeah, that's kind of it. So this is easy. Now rotate the hardest one. Oh god, this is going to be very hard. Okay. So, const floats. I'm just going to copy the GLM implementation as far as is a CML implementation. So this is my implementation of a math library that I made in C as well. But the math library has a completely different concept and works completely differently. So I'm going to try to copy that as far as it even is copyable. Is this 3D game engine or 2D? So I could start it. So as you can see in the title, I am I just have a 2D rendered quad for now, because I need to do a lot of setup. For example, I need to load OpenGL functions myself, make windowing with Win32 myself, which is 500 lines of code, and I needed to do a lot of stuff. So I'm not that far to know, but this engine will be a 2D and 3D engine, and but it's focused on 3D, so model loading and 3D lighting and stuff. So, but I will also implement a 2D renderer for UI and stuff, and like occasionally also 2D games, but it's going to be centered around 3D. So yeah, going to try to implement 3D as fast as possible. So the angle now const float c, which is the cosine of the angle, from which we need to include math. H cos of a, and the sine, so s is just the sine of a. Now the vector 3 rotation axis is vector 3 normalized v. Okay, so vector 3 temp CML vector default. What was that? Default. Don't even have that implemented. Default. So you give a dimension and a value. Okay, so A3. Okay, so we don't really have that, but it's not. Or do we? Don't think so. So let's do vector 3. Create 1 minus c, 1 minus c, 1 minus c. Yeah. Now I do vector 3 mult v source is temp and axis. We need to multiply those. And then we do the rotation matrix. So rotate is equal to matrix for how did I call that? Default? No. Create by value. Value is 0. So rotate dot row1 dot x is equal to c plus. Yeah, okay, we can do is equal to vector 3 create. So x is c plus temp dot x times axis dot x. Then y is temp dot x times axis dot y plus s times axis dot z. Let me think. Like, this is completely different implemented here. Like, you see how it's implemented here. Yeah. So seems correct. Yeah. Okay. So that is going to be temp dot x times axis dot z minus s times axis dot y. Yeah. Okay, now rotate dot row 1 is equal to vector 3 create temp dot y times axis dot x minus s times axis dot z. Now I have c plus temp dot y times axis dot y and temp dot y times axis dot z plus s times axis dot x. Yeah. Okay, seems right. So now this is row 2. Yeah. Okay, so now row 3. So rotate dot row 3 is equal to vector 3 create temp dot z. Like this was such a struggle to implement because like I had no idea how this is going to work in CML, and yeah, I did it kind of. And now I need to convert that to my library. Yeah. Okay, so temp.z times axis dot x plus s times axis dot y. And then we have temp dot z plus axis dot y minus z minus s times axis dot x. And then we have c plus temp dot z times axis dot z, and that's it. Okay. Yeah, nice. Okay, so now what we need to do is, oh my fucking god, look at this. Just look at it. CML vector add, CML vector add, CML vector scalar multiply, CML vector scalar multiply, C. Oh god. So, vector vector 4 row 1 is equal to row 0 first. Row 1, let's do row 1 is equal to vector at vector 3, no, vector 4. Oh, it's not even a vector 3. Vector 4 create. And this is 0, 0, 0, 0. I guess. Oh. Okay. Vector 4 add v. add as a vector for addition. And then vector for addition again, and then vector for scalar multiplication. So addition, scalar multiplication, and we do matrix for get column, and column I1, and rotate dot row 1 dot x. This is a scalar. Yeah. So scalar addition, with add that and vector for scalar multiplication. Matrix for get column, and M2 rotate dot row 1 dot y, yeah. Addition, so we add those. We add this to so those are added, and then the addition. So this is the first thing, and then like the comma. Where should I put it? Like here, and then there's a comma. Vector for scalar multiplication. Vector the matrix for multiplication matrix for get column, M3, and rotate dot row row 1 dot z. Oh boy. Yeah. This is very, very hard to read. Okay, so the comma is here. Yeah, nice. Okay, so this should be it, and it clearly doesn't. Oh. Oh, it's just 0. Oh, const. Okay, so now row 2. So vector for row 2 is equal to, again, vector for addition, vector for addition, then vector for addition again. And then a vector for scalar multiplication. Can you run the program? Yeah. So currently we just have a cube in OpenGL, but everything is like the OpenGL functions are loaded. Like, I'm not using any libraries, I want to say. Like, the window is not with GFW or something, and OpenGL is not with GLAD. I loaded it myself, and the master library I'm using for the color, because the color is uniform in the shader. So also, this is what I'm currently doing. So yeah, this is like everything from scratch, like I can show you. Include directories, just source. So like this is completely from scratch. And now I'm working on my math library, like as you can see here. And like this is my math library at the moment. Yeah. And now I'm working on matrix transformation, which is kind of hard. Very hard. And very clunky in C. Yeah. So, matrix for get column of M, the matrix that we put in, and the first column, and we do rotate.row2 X. Yeah. Okay, now we do a new vector for congratulations, you got a new subscriber. Oh, thank you very much. Oh, like thank you very much. 109 subscribers? What? Like I got in this stream I got like 4 subscribers, which is like very nice. Thank you very much, bro. We very much appreciate the support. Yeah, I'm glad you're here. Thank you very much, bro. Really helps out a ton. Yeah. Yeah, thank you very much. Like that's very cool. I like it. The streams. You deserve more. Yeah, I don't know. Like I'm just streaming. Yeah, just streaming stuff and doing. Yeah, but I want to make videos in the future. Like for example, something like devlogs and good work, by the way. Thank you very much. Thank you very much. Yeah, maybe I'll do devlogs of the engine, which would be very nice. Yeah. So vector for scalar multiplication. No. Matrix for get column M, the second column. We want to multiply that by rotate dot row row 1 dot y. Yeah. Okay, nice. Like that. And yeah, then we have like a vector for scalar multiplication. So matrix for get column M is the third column, and we do rotate dot row 2 dot z. Yeah, this is row 2. yeah. How long will it take to finish your game engine? Yeah, like, I don't know. I'm like, as you can see, I'm doing everything from scratch, which kind of means it's going to take a long time. Yeah, but I don't know, maybe like, as I have like the ground structure done, it's going to not take like like a lot of time, I think. So yeah, I don't know, maybe like to finish, like, I don't know, a year or half a year to like have it at a point where it's like a minimal viable product. Brad, do you know how to join tables and interface programs MySQL via Python? Sorry, but like I have no idea about Python or SQL. Like, that's absolutely not my area of programming. Very sorry, but yeah, I don't know. Because like I do C and C++. I coded in Python once, or like for a half a year, but yeah, I never did SQL. So yeah, sorry for that. Yeah. Yeah. Okay, so let's compile. Yeah, sorry. Can't help you a lot with Python or SQL. Yeah, so sorry for that. Okay, so now this is the last row, which is hard. So vector for row 3 is vector 4 addition first, like always. I want to add a thing where we add two scalars, two vectors again, like always, and like we multiply. Vector for scalar multiplication, matrix for get column, matrix, and we want to get the first column, and we do rotate dot row 3 dot x, and then vector for scalar multiplication, matrix for C. See you then, good night. Yeah, see you, bro. Good night for you, but like for me it's 7, like it's 4:15 p.m. No, a.m. So it's yeah, earlier, not night. But yeah, thank you still, and good night for you. Bye. Okay. Yeah. Matrix for get column, the second column, and rotate dot row 2 dot y. No, row 3. Where are you from? I'm from Germany, and here it's like, this is the time. I'm from India. Ah, like let me see. India time. No, not Indiana. In India. Oh, I see. Yeah. It's pretty late. I get it. Like, this is so cool. Like, people from India and all around the world are in the stream. This is very nice. Very much liking it. Yeah. Okay. So we have that. And now the last step. Vector for scalar multiplication. Matrix for gets row no, get column obviously. Get column M, the third column, and rotate dot row 3 dot z. Finally. Finally. So row z. I also have a sub for you. Oh, thank you! Thank you very much. Like, I'm getting so much subscribers in the stream. Thank you very much for subscribing to my channel. It really helps out a ton, as you know. Like 110 subscribers. Let's go! Let's go! 10% to 200. Perfect. This is nice. Okay, nice, very nice. So now we have the 3 rows, but obviously a matrix 4 has 4 rows. So what we're going to do with the fourth row is a vector for row 4 is just equal to matrix for see ya, bye dude. Yeah, maybe we'll see us next time in the next stream, so yeah. Okay, get column, the fourth column of M. Because the fourth column is not going to change because it's a translation column. And now what we want to do is red dot red. Do we have red? We don't even have red. And where do we create rotate? Here, and red. So let's create red here. So matrix for red is equal to the same thing. And then we do red dot row 1 is equal to row 1, red dot row 2 is equal to row 2, red dot row 3 is equal to row 3, and red dot row 4 is equal to row 4. And then we turn red. Oh, that's it for the stupid fucking rotate function. And it builds. I'm very happy. Oh my fucking god, that took like ages. Okay, now scale. Ah, god. Okay, so matrix for red is equal to that. And then we do red dot row 1 is equal to vector for scalar multiplication, and then we do matrix for get row, get column, M1 and this is v dot x. Easy. So let's have it like that. Then we do red dot row 2 is equal to you can just copy that, and we do column 2 and y, and here we do z and column 3 and a row 3. And then we do row 4 is column 4. So we just set it to the column. Nice. And then we return red. So scaling, perfect. Now look at this very very weird looking here, but whatever. So vector 3 f is equal to vector 3 normalized subst. What is subst? Good work, man. Yeah, thank you very much. Yeah, like I'm trying to do the best I can. So yeah, thank you. Subst is just a scalar subst, and I'm doing vector subs. I think I mean subtract, but I don't know why I wrote subst. Whatever. Okay. So vector 3 subtraction center I. So it's just the distance, I guess, like the distance vector. So vector 3s is equal to vector 3 normalized cross, so vector 3 cross f and up. And const vector 3 u is vector 3 cross s and f. Okay, now matrix for red is equal to matrix for identity, and we do return red, and red dot row 1 dot x. Now red dot row 1 is equal to oh, so row, okay, we do row 1 dot x is equal to s dot x, red dot row 2 dot x is equal to s dot y, and red dot row 3 dot x is equal to s dot z, red dot row 1 dot y is equal to u dot x, and red dot row 2 dot y is equal to u. Wait, row 1 dot y, row 2 dot y is u dot y. It's so fucking confusing. Red dot row 3 dot y is equal to u dot z, and red dot row 1 dot z is equal to negative f dot x. Yeah, and then negative f dot y and dot z and 0 2 1. So row 1 dot z, and then we do row 2 dot z. I'm fucking mindfucked. So row 2 dot z and then row 3 dot z. Yeah. Let me do rot. Bro, I really need a pause. Red dot row 4 is equal to, how old are you? I'm 14. I'm 14. Vector 4 create. Vector 3 dot s and I, and this is negative vector 3 dot u and I. Oh, I'm 15. Oh, nice. Do you code in C++ or in C? Because if yes, then very nice. If I seems about right. Okay, I'm not doing those in the stream because I want to test out normalized. There are too few arguments. Vector dot I. Oh, yeah, true. I hate this. So x is equal to that. Then red, then y is equal to that. And z is equal to that, and f and I. What even is f? Ah, here. Okay. Okay, it builds. So let's try something. Let's do u model, and u model is the model matrix. So let's do u model, and we don't put identity. We do let's include matrix and vector, and in matrix we do matrix transform, and here we just do translate mv. Matrix is matrix for identity, and vector is create, or vector 3 create, let's do 0 in no, let's do 0.5 in x, let's do 0.3 in x, y 0 in z0, and let's put that down here. Oh, it doesn't let me. Okay, so let's build that. Oh my god! We did it! It moved! It fucking moved! Oh my god! Guys. Oh fuck, they got it. Yeah, okay. So, let's make a quick thing. Call it a position vector in here. So, vector 3 player pos or campus. Campus. Frickin' it worked! Oh my god, I love it. I just love it, I love it. Yeah. Okay, so campus. And we just do this. And we bind it and do that and make this for identity, and we just do that. Instead of that we do campus. App.campus. What? Not campus. Campus, not care. Bro, are you joking? Campus. So this is what we upload. And we do if platform is key down. Is this transform stuff in object? Yes, it is. It is, and I did it from scratch and it worked. I'm very happy. We do app dot. What the fuck? Why campus dot x plus equals y times app data time. Where is it? Data time? App state. Data time. Okay. So now, what you need to do is firstly stop that. Just stop it, and then do app dot or rats dot campus is equal to vector 3 create 0 0 0. Perfect. And now let's build. What? Ah, app shader. Oh god. Wait, not W. It's A. It's plus. It's minus. And D. It's plus. Let's rebuild. What? What the fuck? Huh? Why? App campus. Yeah, red campus. If you so wish. What? If we do it here? Oh, this won't work because it's not bound. But if we don't unbind it. Was geht, Bro? Ich habe vieles erreicht gerade. Okay, wir setzen es hier. We set it here. And we do that. And maybe we need to unbind. I don't get that bug. I like. Why? Okay, app. Shader. App campus. Like, the bug doesn't even make sense because it's a freaking shader error. Yeah, now it worked. Oh my god, it freaking worked. But what is the data time? Let's log the data time. I think the data time is not correct. %i data time data app. Das ich auch. Ja, was denn? Also heftig, aber was? Sag was. %f. And parallelly, I'm going to check. No, I'm not going to. Yeah, just wait. 0. What does it say? 0.02. Shouldn't it be 0.002? If we do divided by 10, no, it's 0.00. Okay, like the data time is absolutely weird. Okay, so let's Hä? Digga, ich habe Herr Bäumle geschrieben auf Webundes, dass ich nicht komme. Wegen Zahnspange. Digga, dann gebe ich halt die morgen die Entschuldigung. Meine Mutter hat Entschuldigung gemacht, ich habe die angerufen. Aber dann verstehe ich ihn nicht. Default Data Time 144 Outside Monitor. Ich muss gleich sagen, what the fuck? Warum musst du ins Krankenhaus? What the fuck? Wie ist es passiert? Just say the fucking data time. I think it's 0.007. But I'm not sure. Bro, wie ist es passiert? Aufzugschlüssel für Schule wir checken. Ja, Bro, aber. Okay, now it works. Which is very nice. We can move the fucking thing around with our own math library. Which is very nice, but we don't have data time correctly implemented. Which is bad, but yeah, whatever, let's not worry about that. Yeah. Nice. Okay, so this is, I think that's it for the stream. Like, obviously, we need a projection matrix and stuff. But I consider that a very nice achievement. So yeah, I hope you liked the stream, and yeah, that's kind of it. Ah, no, we need to commit. cd.git add git commit dash matrices in math library and OpenGL shader and in OpenGL shaders. Git push. Bro, aber kommst du morgen in die Schule? Bist du überhaupt noch da? Okay, so send let's see. Nice. Okay, yeah, so this is it for today. Yeah, I hope you liked the stream, and yeah, thank you for all the subscribers and watchers in today's stream. Yeah, so yeah, bye guys.